As a regular to the Railway Museum, many would think I would tire from seeing the same engines, but with such a large museum space, especially in the warehouse, I would always see something new. It's the same when I research a topic for a video. I could see something mundane, then one sentence could change it all. And it happened last week when I was researching into Oliver Bulleid. 1 minute I'm reading his notable achievements, the next second, turf engine. Considering the history my channel has for showcasing the weird and the wonderful, simply couldn't pass it up. Turf, or in its undried form, peat, starts out similar to coal, with the deaf of plants. The only real difference is the environment. Coal was created from ancient forests millions of years ago, while peat was made from plants only a few thousand years old. The geography also played a part. As the forests were drier and were buried by dry leaf and plant litter, the pressure would compress it into solid masses. Peat, on the other hand, because of its wetland, larger plants and trees have difficulty taking root, so smaller plants and mosses began to thrive. As the plants die, they don't fully decay, and it accumulates. In doing so, it also holds water and creates conditions allowing the bog to expand. Due to the decay, the peat also holds a large amount of carbon dioxide. In 2025, one of the largest fires to ever hit Yorkshire happened in North York Moors and destroyed over 9 miles of moorland. Smoke covered Yorkshire and could be seen as far away as Skipton, over 80 miles away. And it took over a month to get the fire under control. And while the culprit was a campfire, the fire found its way into the underground peat. Now, while peat is normally damp, the dry summer conditions had removed the water and it was ripe for burning. The peat burned for weeks, with the firefighters having to dig to find the fire. In the end, it was the September downpours that brought the fire eventually under control. Peat's carbon content made it the perfect fuel for fire. It only needed drying out and cost next to nothing to collect it. The Irish had been using peat to heat their homes for generations. So when Oliver Bulleid joined the Irish Railway from British Rail, he would have no doubt heard from the locals about peat burning, and looking through the railway's history, he would have seen that peat was used as an alternative fuel. The first experiments were in 1848 on engines owned by the Midland Great Western Railway, and it had mixed results. The engines were not designed to run on peat, and only after a few trials, it was decided to return to the more traditional fuels. Other than in dire shortages, coal would be the fuel of choice. After the Second World War, Ireland would take stock of its coal shortages and wanted to develop peat fuel. In turn, the government invested in turf production on a commercial scale. The coal shortage had not only caused rail services to be scaled back, leading to freight shortages, but it also caused power stations to look for alternatives. Reporting to former Western Railway's General Manager James Milne, Oliver wanted to revisit this alternative fuel, and after Milne recommended to the Irish government that invested in diesel would bring no real advantage, he threw his worth into turf. By 1950, he was ready to put his experiments into practice. The candidate for the conversion was Great Southern and Western's Railway Class K3. It was an old engine built in 1903 and had been sent from the UK and rebuilt for the Irish Railway. It was stripped and rebuilt, and this time it was custom made to suit the peat. Firstly, the firebox. As well as the usual dampeners, Bulleid designed a tuyere. Now, a tuyere effectively is an additional pipe designed to bring in additional air to a fire. To preheat the water, specific coils were fitted into the tender tank. Some of the gases were siphoned off and directed to the tender and expelled through its own chimney. The engine was placed on rails in 1952. However, the results were not as good as Oliver wanted. So rather than a conversion, he opted to make a whole new engine. Taking lessons from the previous experiments, he set to work. First, the boiler. It was double-ended, with the superheater and the firebox in the middle, where the cab was. Each end of the boiler was supported by a set of bogies, each containing a trio of axles, chain-driven by a pair of cylinders. The fuel and water was set at one end of the engine and was fed into the firebox and boiler by the way of stokers and augers. And finally, to create a draft, steam turbines were used to generate airflow. When the CC1 came out of the shed in 1957, it was odd, boxy and looked more like a diesel, and it made a statement. However, things didn't go well. The engine had a tendency to leave more than steam on the line side and wanted to use its sparks to do some line-side gardening of its own. To curb this, the engine was fitted with a spark arrestor, but modifications couldn't fix the fact that the engine guzzled water and fuel at an excessive rate. But despite this, the engine worked okay. Oliver hopes that with further development, others would follow. However, when Oliver retired, so did the dreams of the CC1. It was quietly retired in 1963, and almost unknown to all, was broken up in the decades that followed. Unfortunately, had Oliver's locomotive had succeeded, its very fuel would have probably put an end to it. Peat is a good burner, true. However, it is heavy in carbon, and burning it releases a lot of carbon dioxide. The removal destroys moorland, decimates wildlife habitats, and can change the whole ecosystem. Governments have recognised the impact of peat removal can bring, and its removal on an industrial scale is heavily restricted, with some banning it completely. It was a unique idea brought upon by a necessity, and to be fair, it took a brave man like Oliver to at least give it a try.